Hello everyone. Today we're going to see another topic in gate programming and data structures. Topic is storage classifier. You have 1 minute to solve. Okay, let's discuss the answer now. So storage classifier. It's one characteristic we can say about a variable. Previously in other videos what we saw about the type, the different memory, and we can say about the scope. So storage classifier you can think as one characteristic which talks about the scope and the lifetime. When we say about scope, suppose you had a function. Scope refers to the area it can be accessed. If we declare a variable x, right, we can only use it here. Suppose in another function, if you try to use this variable x, right, it will be giving error because the compiler doesn't know which variable it is. So scope only tells you about where you can access. Now lifetime. So if you have seen in memory the concept of creation and deletion, right? Lifetime is from where it got created in memory to where it got removed to the memory. Now let's look at the scope and lifetime of static. So static, it has the scope of a local variable, that is local scope to that body of the function, but it has lifetime globe. Remember that when we say scope, we are only telling about the access. So in terms of static, we can only access within the body, but the lifetime is global. Means that compiler is only going to assign the value created in memory only once. And next time whenever you try to use it, it's going to use the same memory value only. We'll get a bit more clear about this idea when we see this question. So here in the question we can see we have one static variable x being used in this function. Note that we can only use x in this function and nowhere else. So first time we are calling function p. So the compiler, at compile time what happened is that x was initialized memory with value 1. So when this function call is happening, right? So compiler already made in memory one value for this. It's not going to again create a new variable. So we're going to use this memory only. So x plus plus and it returns 2. So this x. Note that this x and y are local variables. It does not refer to the static. So a local variable x has value 2 for main. So next time you call function, we see this x, right? It refers to the static memory variable x. So it increments that and returns 3. So the local variable to main now gets the value 3 plus 2, 5. So we get the value of 7. So note here that in main we are having one local variable x. And in the function p, we were having one static variable x. So this local variable x is having a different copy and the static variable x is having different copy. So now when we said the scope is local, right, it's only accessible here. But when we were talking about the lifetime as being global, we were referring to the memory. That is, so you can think that at compile time, when the compiler sees static, it is creating this memory. And every time that compiler sees that word static, right, it is going to refer to what it created at compile time. Not like in the case of this local variable. In case of local variable, what happened? Every time it is seeing that in text declaration, new and new copy is being created. But in static, that doesn't happen. Let's have a quick overview of whatever we learned so far. So static has a local scope. Remember that the scope is local, but the lifetime is global. Second time function p is called, since x is static, it does not create a new variable and it reuses the existing value. That's why every time when we were calling, it was incrementing that same value itself and not creating a new value like in the main. Whatever we saw, a new fresh value was being used for a local value. So suppose this static keyword is not there. Suppose it's int x equal to 1. Every time the function is called, we'll have a new copy and it will be assigned with value 1. But since it is static, at compile time, it was already allocated a value and we're just reusing that every time it is being called here. Thank you.